Okay, section 2.1 is the addition property of equality. So we're going to be dealing with linear equations and solving linear equations here. So a linear equation with one variable can be written in the form ax plus b equals c. A, b, and c here are real numbers, and our one variable is just the x that's here. So for a couple examples of this, we can have something like 2x plus 7 equals 10. Or we can have negative x minus 3 equals 0. Or x plus 1 equals 5. So these are just random examples for linear equations with one variable. So a solution of an equation is just going to be a number that makes the equation true when plugged into the variable. And an equation is solved for by finding the set of all solutions, which is called the solution set. And equations with exactly the same solution sets are equivalent equations. So to solve equations, we're going to be generating equivalent equations until we have the variable solved for. So we're just trying to get the variable alone on one side. And the first way we're going to be doing this is using this addition property of equality. And we'll see, we'll also be using subtraction. So it's kind of the addition and subtraction property of equality. And what we'll be doing after we solve these equations, we'll be checking our answer by plugging the solution that we found back into the original and making sure that it results in a true statement. Okay, so for what exactly the addition property of equality says, so if a, b, and c are real numbers here, then the following equations are equivalent. So if we have a equals b, so that just means we have something equals something. That means if we add a number, which we're just going to call c, if we add c to both sides of the equation, that's not technically changing anything. And similarly, if we take it and we subtract a number to both sides of the equation, that's also not changing anything. So that's what the addition / subtraction property of equality states. Okay, so let's do a bunch of examples here. So let's solve the following equations. And I'll also check the first maybe 2 or 3 just to make sure that our answers are correct. Okay, so for the first one, we have x minus 4 equals 10. So we want to solve for x here. So it's what minus 4 equals 10. So maybe you can do this one in your head, but let's do it using this addition property of equality. So in order to get x by itself, we need to get rid of that negative 4, the minus 4, which means we need to add 4 to both sides. So we have to do the opposite operation to get it to the opposite side. Okay, so this is actually going to cancel those on the left-hand side, and we're going to be left with x equals 10 plus 4, which is 14. Okay, so that's our solution. So let's check it. So a little check. So we're saying x minus 4 equals 10. And we're going to plug in 14 into x to see if it works. 14 minus 4 is 10. So we get 10 equals 10. That's a true statement, so we know that we're correct. Okay, for the next one, x minus 7 equals 0. So for this one, we want to say what minus 7 equals 0. So once again, we want to generate an equivalent equation. We need to do this by adding 7 to both sides. That will cancel it over here, which means that'll give us x by itself, which is what we want. 0 plus 7 on the right side is 7. And a quick check. Checking x minus 7 equals 0. We're going to plug in a 7. 7 minus 7 equals 0. That's true. We get 0 equals 0, so we know we're right. For the next one, negative 20 equals x minus 8. So this time the variable is on the right-hand side of the equation. That's completely fine. It doesn't even matter. If you really wanted to, you could write this as x minus 8 equals negative 20, but we don't have to. So we need to solve for x. So we need to get this negative 8 on the left-hand side. So we need to add 8 to both sides. Cancels it over here. So we're left with x on the right-hand side, negative 20 plus 8 on the left-hand side. Negative 20 plus 8 is negative 12. So I'm just going to rewrite it so the variable's on the left. It's just better form. So we have x equals negative 12. Okay, and this will be the last one that I check, just because I think we get the idea. So we get negative 20 equals x minus 8. We plug in our solution, get negative 12 minus 8. And negative 12 minus 8 is negative 20, so it checks out, so we know that we did it correctly. If it didn't check out, if we got a false statement, then that would mean that we did it incorrectly. Let's do several more here, get a little bit harder. So we have negative 7 equals x plus 22. So to get x by itself, we need to subtract 22. Oops. So it's going to cancel on the right-hand side. On the left-hand side, we're going to end up with negative 7 minus 22. That's going to give us negative 29. So we get negative 29 equals x, which means x equals negative 29. So I'll skip checking for now. You can keep on checking if you want. So for E, we have x plus 13 equals 11. So in order to solve for x, to get rid of that plus 13, we have to do minus 13. So it cancels over there. 13 minus 13 equals 0. So we get x equals 11 minus 13. So we get x equals negative 2. So for F, looks a little different. We have 6x minus 8 equals 7x. So we have a variable term on the left as well as a variable term on the right. So in order to get the variable on one side, it's going to be easier if we subtract 6x on both sides. So we're going to subtract that whole entire term. The reason is on the left-hand side, now we're left with negative 8. On the right-hand side, 7x minus 6x, combining like terms, that's going to give us 1x, which is just x. So we get x equals negative 8. So we always want to get all the variables on one side, all of the constants on the other side. And in this case, we recognize that if we subtracted 6x, we would get 7x minus 6x, which would give us our 1x that we're solving for. Okay, and then even a little bit harder for G. We have 3/5 x plus 15 equals 8/5 x. So once again, if we want to recognize that if we want to get all the variables on one side, and we recognize that if we subtract 3/5 x on both sides of the equation, it's going to cancel on the left-hand side. We're going to get, I'll do this in 2 steps. So we get 15 equals 8/5 x minus 3/5 x. 8/5 minus 3/5, they have common denominators. 8 minus 3 is 5. So 5/5 x. 5 over 5 is just 1. So we get x equals 15. So that gives us x equals 15. So 15 is our answer. For H, for the next one, we have 8 minus 6p equals negative 7p plus 5. So we're trying to solve for p here. So we want to get all of the p's on one side and the constants on the other side. So this time, it looks like if let's worry about the variables first. I'll come back to the constants in a second. if we add 7p to both sides, it'll cancel on the right-hand side. Negative 7p plus 7p is 0. On the left-hand side, we would get 8 minus 6p plus 7p. That would be plus 1p. So 8 plus p equals 5. Next step, we have to get rid of the 8. Get rid of the 8 on the left-hand side by subtracting it. So it cancels on the left-hand side, and we're left with 5 minus 8 on the right-hand side. So we get p equals 5 minus 8, so p equals negative 3. Once again, you can check all of these by plugging them back into the original and make sure you get a true statement. Next one, a little bit more confusing here. So we have 3t minus 12 plus t plus 2 equals 5 plus 3t plus 2. So before we work with both sides of the equation, let's work with one side at a time and simplify it. So on the left-hand side, combine like terms. So we have 3t plus t. Oops. So we have 3t plus t, which is going to end up being 4t. And then we have negative 12 plus 2, which is negative 10. Okay, actually, no. So that's 4t minus 10. And on the right-hand side, we have 5 plus 3t plus 2. Combine like terms, that's going to give us 3t. 5 plus 2 is 7. Okay, and now we need to get all the variables on one side, all the constants on the other side. So if we subtract 3t on both sides, that's going to cancel on the right-hand side. 4t minus 3t is 1t, which is just t. So t minus 10 equals 7. We want to add 10 to both sides. So this is going to give us t equals 7 plus 10. T equals 17. Okay, and then this looks like the last one right here. We have 3 times 2 plus 5x minus 1 plus 14x equals 6. So we want to simplify that left-hand side first. So to do that, we actually have to distribute. So distribute, we have to do 3 times 2, 3 times 5x. 3 times 2 is 6, plus 3 times 5x is 15x. Now we have to distribute what is essentially a negative 1. So we get minus 1 minus 14x, and then equals 6. Okay, and then we want to combine like terms on the left-hand side. So we have 6 minus 1 and 15x minus 14x. So 15x minus 14x is 1x, so just x. And then 6 minus 1 is 5. So we get x plus 5 equals 6. Now it's pretty simple. All we have to do is subtract 5 on both sides. Cancels on the left. We get x equals 6 minus 5. So x equals 1 is our answer. I'm just going to check this one just to end with one that we're checking on. So we had 3 times 2 plus 5x minus 1 plus 14x equals 6. So let's plug in a 1. Make sure we get the true statement. So it's going to be 3 times 2 plus 5 times 1 minus 1 plus 14 times 1 equals 6. Okay, so simplify, just make sure your order of operations are correct here. So 2 plus 5 times 1, that's 2 plus 5, so that's 7. 1 plus 14 times 1, that's 1 plus 14, so 15. So we get 21 minus 15 equals 6, which is 6 equals 6, which is true, so we know that we did it correctly. Okay, so that's it for section 2.1. Section 2.2 will get just a little bit more difficult.